For this problem, we're going to factor and solve. So the first thing we do when we factor is we check to see if there's a greatest common factor, which in this case, we can divide each term by 2. So if we divide everything by 2, we get x to the 8th minus 256. Okay. And now we want to see if this is a difference of squares to see if it can break down more. And it looks like it is, because x to the 4th squared is x to the 8th, and 16 squared is 256. So we can factor this second factor into conjugates of x to the 4th and 16. And now we keep checking all of our new factors to see if they can factor further. It looks like this second factor is a perfect square. Sorry, a difference of squares. The third factor is not, because it's a sum of squares, not a difference. So the second factor can break up into x squared plus 4, x squared minus 4. All the other factors just remain as they were. All right, now we check one more time. It looks like we only have one more difference, and both of those are perfect squares, x squared and 2 squared. So this can break down one final time into conjugates of x and 2. So that broke into those two, this broke into those two, this broke into those two. Okay, so this here would be our factored form, and now we solve each of those mini equations, so to speak. So x squared plus 4 equals 0. This is a quick one of just x equals -2. Another quick one of x equals 2. And this would be the equation x to the 4th, plus 16 equals 0. So we have 2 right here, and then we'll solve these two. X squared would equal -4. So when we square root that, we'd have positive and negative 2i. So there's 2 more solutions. And over here, we would subtract 16 and then take the 4th root. And all you need to know now is that any even root on a negative number is imaginary. Just like when you square root a negative number, it's imaginary. All we expect you to know now is that this is going to be imaginary, and stop at that. All right, so those are our solutions. Positive and negative 2i, -2, positive 2, and then we'd have some imaginary numbers here from the 4th roots.